Hi, this is Ryan Long, and I'm going to be going over homework problem number 2, which reads: a parallel plate capacitor has a area 250 centimeters squared and a diameter of 2 millimeters. The capacitor is charged to a potential difference of 150 volts, and the battery is disconnected. A dielectric sheet of thickness 1 millimeter is placed between the plates, exactly in the middle, so there is a 0.5 millimeter gap between the dielectric and each plate. First, find the capacitance before the dielectric is placed. To do this, well, first you have to find the area and make sure you find the area in meters squared, not centimeters squared. And then you just apply the equation: the capacitance equals epsilon naught times area over distance. So you do that calculation, you get 1.1 times 10 to the negative 10 coulombs per volt. And question 2, or part B, is asking to find the charge before the dielectric is placed. We just use the equation capacitance equals charge over voltage and solve for the charge. When you do this, you get 1.65 times 10 to the negative 8 coulombs. Part C is asking for the induced charge on the surface of the dielectric. And the induced charge is equal to tau times 1 minus 1 over k. And k in our case is equal to 3. So first we need to solve for tau, which is just the charge over the area. And when we do that, we get 6.6 times 10 to the negative 7 coulombs per meter squared. Then the induced charge with k equal to 3 is 4.4 times 10 to the negative 7 coulombs per meter squared. Part D is to find the electric field between the dielectric and the plates. To do this, we're going to use tau and the induced charge from the equation before, all divided by epsilon naught. When you do that, you're going to get 2.48 times 10 to the 4 newtons per coulomb. Part E, scroll down. Part E is asking for the E field in the dielectric. To do this, we're just going to take the electric field that we found from the previous question and divide it by k. When we do that, we're going to get 8.26 times 10 to the 3 newtons per coulomb. Part F is asking for the voltage drop, or the potential between the two plates, including the dielectric. And this is just going to be equal to the original voltage divided by k, which is going to give us 50 volts. And the last question, part G, is asking for the capacitance including the dielectric. And we just use the equation C equals C naught times k. And when we do this, we get 3.3 times 10 to the negative 10 furlongs.